about 40 minutes or so to take you through reinforcement learning and how DeepRacer, autonomous racing, fits into that world and makes it essentially practical. Everybody can get going with reinforcement learning using DeepRacer. And the bar that I use typically is to say, if you've ever used an Excel formula, then actually you've got enough prior experience to start becoming the next autonomous racer. So who am I? So just building upon the introduction that Bill gave me. So my background is as a technical architect. I tend to work more at the sort of senior end of things. I tend to lead projects and work between the board and development teams, and mostly around consumer-facing brands, which of course at the moment with COVID, many of them are highly impacted, which is a shame. But it's good news for you because I have more time to give some of these talks. As Bill said, I'm also founder and CTO at Deep, and you did get that right. So Deep is a machine learning consultancy, and I'll tell you a little bit more about that in a moment. But the reason really why I'm here today is that I'm founder of the Deep Racing community, and that is a worldwide community of over 2,000 people who have tried DeepRacer and are part of the DeepRacer phenomena over the last 12 months. And as a result of my efforts there, Amazon have recognized me as a machine learning hero. But my goal today really is to impart some basic introduction knowledge around reinforcement learning and how DeepRacer helps you learn the mechanics around reinforcement learning and puts you on a good journey forwards to developing your expertise. So very briefly, Deep is a consultancy, and we broadly do strategy. So we help businesses understand how they can apply data and machine learning in particular to grow revenues, optimize costs, and transform customer experiences. And of course, then that ties into actually delivering solutions. So we're not a technology provider. We work with the best startups, medium, large size companies who have got great technology, and we put the right components together to deliver a solution for clients. The other bit we do is enablement. So we actually help teams become more self-sufficient. And partly this is through training, partly it's through ways of working and tooling. But the training is actually where we also use DeepRacers. We run one-day events for customers where we'll get everyone together. And the goal really is about helping your whole IT team. Everyone, not just developers, not just the guys and girls at the bottom, but all the way through to CTO, business analysts, project managers. Everyone gets their hands dirty. And it's a really fun day. Enough about that. So a little bit background to how I got involved with DeepRacer before we dive into that. So once upon a time in a land far, far away, London, and actually almost a year ago, I went to the AWS summit. And if any of you have been to these summits over 2019, you would have seen a track just like this in the grounds where people were able to get their hands on DeepRacer. The London summit was actually the first summit after DeepRacer was publicly launched last May. So actually DeepRacer is 1 year old today, which is quite exciting. But this is me on the track, and this is me trying out my very first model on a car. And it did pretty well. I managed to get to the top of the board for a little while. At the end of the day, I ended up in, I think, 5th position. But in the process, DeepRacer TV interviewed me and everyone else, and you can see that episode on YouTube. If you just Google for DeepRacer TV London, you'll find an episode with me in there and many others from that London program. And there's actually episodes from about 5 or 6 different races around the world, as well as the finals, which were held in Vegas in December last year. And as I say, I ended up in 5th place, which was pretty fun. But one of the things I took away from the day was a real sort of excitement that the other people around me who were racing, particularly the people in the top 10, actually very few of them were experts in machine learning or AI. And we had a really good conversation, and I didn't want that to finish. So I took all their contact details, I connected with them on LinkedIn and other places. And out of that, I set up a little community just to carry on the conversation. And that was the breadcrumbs which started the DeepRacer community, as I say, just under 12 months ago, which has now got over 2,000 people in worldwide. And at the end of the season last year, I was the best overall runner-up. So there were 64 places in the finals in Vegas, and every finalist got a all expenses paid trip to Vegas to take part in the competition. And as I say, I was the best overall score pointer in there. Itaga was my racing name on the DeepRacer League in the process there. Okay, so what is DeepRacer? So DeepRacer really came about by a realization from Amazon that actually machine learning can be quite difficult to get going with. There's a real perception that actually this is something that only PhD experts can do. And I guess in a way, just traditionally, historically, that probably was true. Getting together the pipelines and all the different technologies and the data sets before you could even start learning the algorithms and the techniques was quite a burden and did require a lot of expertise. So Amazon asked themselves, how can we actually take away a lot of that pain and get developers to the point where they can start learning about reinforcement learning quickly? How can they do what Amazon does well and actually abstract away setting up all the environments, all the tool chain, and get you to the point where you're actually seeing what are the effects of different characteristics in terms of how you can train your model. And so that set them the nugget of goal, and they came up with DeepRacer as the answer to that. So DeepRacer is actually three things. There is a car, which is a 1/18th scale autonomous race car. And the picture here is actually from the first generation car from 2019. Amazon have actually launched a new generation one, which has two cameras, stereo vision and a LiDAR on top. But it's not available to be purchased just yet. So we're still working with these. But actually, you don't need one of these cars to take part because most of your time and effort and energy will be spent in the virtual simulator. And that's actually where we teach the car how to drive. And we actually apply the concepts around reinforcement learning to get the car to behave in a way that is successful for us. At the end of that process, you can opt to then download it and put it onto a car. And that's essentially what Amazon does at each of the summits. Of course, with COVID, all those summits have now been cancelled. So actually the virtual simulator and the virtual racing environment have become even more important to that process. But the final and most fun bit about DeepRacer is the DeepRacer League. So I've touched upon this already, but for the second year now, Amazon are running a virtual league. And actually, hopefully, after today's session, every one of you can actually go home and log on to the Amazon platform and start building your models and taking part in the competition. And who knows, maybe you can be one of the winners who will get a place, all expenses paid trip to Vegas in December this year, assuming, of course, we're allowed to meet in December by then. Okay. So what is reinforcement learning? And I appreciate, with AI Camp, there is a lot of experts in the community already. So apologies if I'm teaching you things already, but just in case there's anybody out there who doesn't quite know what reinforcement learning is, I just want to give a little introduction to that. So obviously in the space of AI more broadly, machine learning is a subset in there. And my understanding of machine learning versus AI is a way of essentially representing, mimicking human behavior in pretty much any task. And I'll be honest, we're probably quite a far away in terms of getting the utopian models that can actually apply themselves to any problem in any situation. Machine learning takes a more specific subset. For a given problem, we can develop a model that actually mimics the behavior and probably does better than a human at that, solving that problem, that discrete problem in there. Now, within machine learning, of course, then it breaks down even further. And there's actually lots of different types of machine learning out there. The three big ones, which most of you will be familiar with, is supervised learning, unsupervised learning, and reinforcement learning. Now, again, forgive me if you already know these things, but for everyone who's just getting going with machine learning, supervised learning is where we actually have a big data set, and these data sets ideally are quite clean, and we label the data in there, either, for example, tagging pictures to say this is a dog or a cat, and then we get a big data collection of maybe 10 or 20,000 pictures that say this is a dog, this is a cat. We put that into an engine like AWS SageMaker, and it will give you out a model, a neural network that allows you to predict, given a new picture, whether that picture is a dog or a cat. Now, if you put in a picture of a squirrel, of course, then it will get confused and it may probably label it as a cat in the process there. But you need big, clean data sets, and every bit of data is tagged with the answer. And is that correlation then that the model is learning to predict? And this doesn't have to be discrete. It can be predicting, for example, house prices or stock prices into the future on a more continuous spectrum. Now, with unsupervised learning, we still have big data sets, but we don't label the data. What unsupervised learning is trying to do is look for patterns and groups within the data set that says, given a piece of data, it is quite similar to these other bits of data. And so as a model, you can use this in interesting ways in that, although it won't tell you what that means, if you know this bit of data is similar and belongs to that group, then you can reasonably take action based upon the outcomes you've seen from anyone or anything that's previously been in that group. And so this is good for things like Spotify music recommendations, where the music taste, the things you listen to, have a discrete pattern. And actually, by using an unsupervised model, we can actually find the groups of other listeners and other songs that correlate well to your listening tastes. And then given a new song, can predict whether or not that is going to be in the group of songs that you're going to appreciate. Now, it also needs a big data set. As I say, we don't label the data in there. It will just give you correlations. So with both supervised and unsupervised, we have lots of data and examples to drive and train our model into the process. Now, if you think of a challenge like reinforcement learning, with autonomous racing, the challenge there is how could you create a big enough data set that allows you to actually get every point of the track with every angle, with every velocity, and learn the behavior off the back of that then that allows the car to drive. It would be a pretty difficult challenge to use a supervised or unsupervised model in there. And as I say, that's where reinforcement learning comes to the rescue. So reinforcement learning actually inverts the model. What we're doing is actually building up our training data set as we go along. So we start with no data. What we start with is a simulation of our problem, and we allow something to explore that simulation and learn the consequences of doing that. So to make this a little bit more practical, the best example of this is like teaching a dog to sit. So when you get your dog to sit, you give it a treat, you're reinforcing positive behavior. Over time, the dog will then learn that actually this is a good outcome is if I sit, when I hear the word sit, I'll get a reward. Even if ultimately you stop giving the reward, the dog will still behave in the same way. And it's the same with autonomous car racing and reinforcement learning generally. As the agent, as the item is exploring that environment, we can actually give it rewards to say this was a good thing you did or a bad thing you did. And over time, it then learns to actually reinforce its knowledge about what works well and what doesn't work well, and to predict off the back of it. So there's some key terms in reinforcement learning that we need to cover just very briefly, and they all relate to one another. So in the middle there, we've got an environment. And as I say, that is key, fundamental to reinforcement learning. You need to be able to build a simulation of your problem. Now, of course, with DeepRacer, that is a virtual racetrack, a 3D model, an environment where we have some of the key characteristics that can influence car performance. So we have friction and basic physics around gravity and things like that. But we don't go everywhere. Things like air resistance is not modeled because at the scale we're talking about, that really doesn't have a huge impact on the car's performance. But in broader terms, in reinforcement learning, this environment could be anything. It could be a stock market simulation. It could be a drug experiment where we're looking at how individual atoms and chemical bonds react in a certain environment and whether they achieve certain behaviors. So we have an environment, we have our racetrack, and we obviously then need something to explore that, and that's your agent. So your agent will explore the environment, and again, in our case, that's a simulation of a car, and the car has the ability to take certain actions. So these are typically discrete actions, so we can steer left and right or straight ahead, and we have speed. We can go fast or we can go slow or somewhere in between. So the combination of steering and speed gives us a spectrum of possible outcomes that the agent can take in that environment. Now, as the agent does that, we allow the agent to randomly take actions in that environment. And as it does so, the state of that agent in the environment changes. So as it progresses around there, it may be on the track or off the track. It may be near an edge or not. It may be crashed, for example, if it's hit into an object that's on the track. And as it does this iteratively through lots of episodes, lots of attempts through that environment at solving the problem, and in our case, an episode is from the start of racing to the point we crash, which could be coming off the track or hitting an object. It could also be actually to the point of achieving our goal, which is getting a whole lap. So that is an episode. And we do that lots and lots of times, iteratively over and over again. Of course, this is where the cloud becomes great because we can scale this very cheaply and very quickly in doing so. Now, as we get those episodes, as the car and the agent explores the environment, it does different things. And that is where the reward function comes in. Now, the reward function in reinforcement learning is probably one of the most critical things you need to learn, and actually is where you're going to spend most of your time in actually building models, be that for autonomous car racing or for something else. So the reward is just like teaching the dog. So when the car does an action that we deem to be a good outcome, then we give it a positive reward. And if it doesn't, we give it no reward. Actually, giving negative rewards kind of doesn't work too well, at least in DeepRacer environment. So if the car does something we don't like, we just don't reward that behavior. So let me give you an example. As the car goes around the track, we can give it a reward. And so the longer it stays on the track, it will accumulate more reward. And it is then mining into that understanding that if I take these actions, I'll get more reward, that the car then learns to actually see the features of the track that correlate good rewards and the good actions that led to more reward. And then over time, it gets better. So looking at those environment from the car's perspective, if it sees the track boundaries, for example, and the features of the image that show a track boundary bearing around to the left, and it takes actions 1, 2, or 3, which happen to be steering left, it will end up getting around and getting reward. And that's a behavior it learns and will then try again on the next iteration once it's been rejigged. So, reward function. As I say, the reward function is probably the most important part of reinforcement learning. And so we're going to focus a little bit on how that works for DeepRacer. So as I say, it incentivizes a particular behavior and it's at the core. So you need to get the right reward to incentivize the right behavior. If you inadvertently reward the car for crashing, that's what it will learn to do. And so you have to think very carefully about how you could structure that. So taking our problem, we have our agent, we have our environment, a track, and we have a goal. Our goal ultimately is to get around the track. And in fact, get around the track safely and in one piece, and in a way that actually gets us around the track quickly. So as a human, you can look at this problem and say, well, that's pretty simple, really. You just go straight down the middle of the track and you're going to be at the end. But from a computer perspective, this is quite challenging. If you take your traditional sort of functional programming, even with libraries like OpenCV, trying to actually interpret what you're seeing and code that traditionally would be a very complicated and a huge program. So with reinforcement learning, with machine learning in general, we need to find a way of actually getting the model and getting the computer to learn the outcome we want to get to and actually find an optimal neural network that gives us the answer we need. So reinforcement learning using a reward function over this problem, one way we can do it is split the environment up into a grid. So ideally, again, as a human, we can see the most optimum path, the quickest path, is probably straight down the middle, the center line of squares, from where the car currently is to the finish line at the end. And then if we overlay on this, though, any other alternative to that is going to take us a little bit longer. So with a reward function in this case, and this is obviously a very simplistic reward function, if we gave 2 for every time the car is in the center of the track, and we gave 0.2 when it's just slightly off center, and we gave nothing when it's at the edge and has crashed, then we have a reward that says look, you can go where you want to in the track, but I'm going to give you more reward when you drive down the center. And in doing so, then, when the model trains, it learns to correlate that actually the center dotted line is actually probably the feature of the image that's going to give it the best reward and the best outcome. And it's going to try and keep that in the center of the picture. So as then the car goes through an episode, and recall an episode is one experience through the environment that leads to a terminal state, be that a crash or getting to a success. It will randomly take actions initially because it has no experience of knowing what works well. And so in this case, it takes one step forwards and then it takes a step left, another step left. So in this case, it's got a reward of 2 plus 0.2 and plus 0. So 2.2 is the total reward for that episode. Now, doing this lots of times, iteratively, over and over again, allows us then to experience what different behaviors lead to different outcomes. So in this case, it's still wobbling a little bit, but it's got a better outcome. It's got 0.2 plus 2 plus 0.2, so 2.4 in total. That's better than that first episode. So that combination of behaviors where it steered left and then back into the middle earns it more reward. And of course, then when you do this over and over and over again, it will eventually find the path down the middle, which leads to the best outcome. And so you see on the left-hand side here, a chart that shows, as the number of episodes goes on, what is our total cumulative reward? And you hopefully, if you've got a good reward function, will see that curve sloping upwards. It doesn't necessarily mean it has to go up every single step, because actually the car actively tries to find better outcomes, and it ultimately doesn't know when it's got the perfect outcome. But as a human, again, we can see it straight down the middle, and eventually it gets to a model where we have finished exploring the environment and we can actually start exploiting that. As I say, iteratively over and over again, the most optimum path is down the middle, and actually beyond that point, there isn't any more training we can do that will get that model to go any better. So that's the point at which we say the reinforcement learning model has converged. It's reached a point where actually you'll see in the reward there and the outcomes levels off. Now, if you trained that for another 10 hours, it's not going to get any better. And in fact, it's probably going to get more badly performing, because it's going to get too used to the environment and expect a perfectly straight track in this case. Of course, the real world isn't perfect, and there's lots of behaviors in there which we don't want to get to. So doing that over and over again, you can see the difference between exploring. Hopefully this video is showing for you. Exploring, you end up crashing quite a lot because it doesn't really know too much. It's trying to find the best combination of actions to get a reward. Eventually, it starts to converge, and we can exploit that to actually get around the track. That's the point we're ready to race, be it in a virtual environment or on a physical track. So this is taking a little bit longer. Okay. So once you've got your model ready, there are essentially two ways you can race it. You can race it in the virtual circuit as part of the league. In fact, you don't even have to enter the league. You can evaluate it in your own environment, but it's more fun if you do take part in the competition. And you should have been able to go to any of the summits around the world, the physical races. Of course, with COVID, pretty much they've all been cancelled so far. We hopefully might get a couple towards the end of the year. But instead of that, then Amazon have switched the summits to being a virtual summit, and consequently, there's also a virtual DeepRacer race as part of the virtual summit circuit. Either way, there's going to be, I think it's like 78 places, prizes, where you can win an all-expenses paid trip to reInvent Vegas in December this year, and there's some runners-up prizes where you can win one of the car. And hot off the press today, if you train during May, all of your training costs using the Amazon resources and the Amazon console are going to be 100% reimbursed by Amazon at the end of the month. So this is a great time. This is the perfect time to get going, because there's literally no cost to this. When there is charges, it roughly costs around sort of $5 per hour of training. So it's not extortionate.
Hi, Linda. Sorry to
Yes.
interrupt. Seems like we lost your screen. Are you still displaying share screen? Okay, now I can see you.
You can? Yeah. Okay.
Yeah, I mean, like in the last 2 minutes, we didn't see anything.
Okay. Apologies. I'm not sure what happened there.
Okay. Anyway,
okay.
now
At
it's
least you
fine.
can see it now. Good. Okay. And in the 2020 race, there is actually 3 race formats that you can take part in. So there's time trials, which is essentially, PowerPoint has just crashed on me. So it's just going to restart, apologies. Give me a moment. So yes, as I say, there's 3 race formats in the 2020 league. There's time trial, which essentially is getting around the track as quickly as you possibly can. Then there's object avoidance, where Amazon put a number of boxes on the track, and head-to-head, where actually we get 2 models to race against each other. So they're just different ways of getting a different experience, because obviously rewarding for one of these is quite different to rewarding for the others. Are the slides back on the screen now, Bill?
Okay, yes.
Good. Right. Okay, so the virtual simulator. Before I give you a quick demo, just underneath the hood, what is DeepRacer? So DeepRacer uses a number of off-the-shelf AWS services. In particular, it's using Amazon SageMaker, which actually trains a neural network to give you your model and takes the data. As I say, with reinforcement learning, we are generating data as we go through, and that is then fed into SageMaker with the rewards to then learn what is the optimum tuning to the model to give you the best outcome. The actual virtual environment is built using AWS RoboMaker, which is a great product for simulating pretty much any sort of physical 3D world problems. It has a good physics engine in there as well. And behind that, then it's using S3 for storing the models and the outcomes. It's using Kinesis video streams, so you can actually see what the car is doing and follow along. And there's CloudWatch, which lets you get log entries and metrics. And that's really important actually to learn how your car is performing, so you can then analyze it and then work out how to optimize your reward in your next cycle of training. And that pretty much is the process. You create your model, you define what rewards you want to have, what action spaces, so what steering and what speed combinations. If you have lots of actions, you're going to have lots of choice, and the car will have lots of choice to get around the track. But it's going to take the model longer to actually learn what is the best action. If you have too few actions, it will train quickly, but maybe you won't have the right combination of speed and steering to get her out of a particular situation on the track. And then the hyperparameters we won't talk about too much now, but there's additional things you can do to tune the model to give you better outcomes and the way it accounts for the rewards in determining what it is. So you build your model, you configure training, you then train it for a period of time, typically a couple of hours. You then evaluate it to see how it's done. And that again can be on your own as part of the league. You'll learn from that, tweak a model, and then go through the cycle again and again. And eventually you'll get a model which you're happy with and is racing well. Okay, let's go to the demo then. Let's see, hopefully this still works. So as I say, DeepRacer has been designed to take care of all of the heavy lifting for you. So SageMaker and RoboMaker and all the services behind the scenes, you don't need to play with or touch with. Once you've actually got used to what's going on, you can very much lift the lid and start delving into the inners. But day one, you don't need to do that at all. So when you log into the AWS console, if you simply search for DeepRacer, you'll find it in the list of services. It's only available in US East 1, so make sure you're in that region when you're doing there. And the first thing you'll want to do is go to Get Started. I've already done this because it takes about 5 minutes. I didn't want to waste your time. The first thing you have to do is set up your resources. You click a little button here where it currently shows me Reset. That will set up all the infrastructure behind the scenes. There's no cost at that point. The cost only comes in when you're training. And as I say, for May, all that cost is going to be reimbursed. So once your resources are set up, then you can start getting into actually creating your car and configuring your car. And that's done in the garage. So you go to the garage and we can build a new vehicle. So there's a few choices. As I say, the new car actually has a choice of having 2 cameras, and optionally you can put a LiDAR on top. Now the LiDAR actually adds quite a lot of complexity to the model and the training time. So I would suggest for your first attempt to get going, just stick with the single camera, no LiDAR, and that works brilliantly well for the time trial formats. In the bottom, then you've got the choice of a 3-layer CNN model or 5-layer. The trade-off here is with a 3-layer, it will be much, much quicker to train, but it may not be able to learn as complicated behaviors as it could with a 5-layer model. So particularly when we're doing head-to-head racing and trying to, for example, learn how to block the car behind us from passing us, that's quite a complicated behavior. But for the moment, the quickest, cheapest thing to do is to select a 3-layer model. It will train really quickly, and for time trial, that's perfectly adequate. So single camera and a 3-layer CNN. The next choice you've got is steering.
Hey, Linda, sorry to interrupt again. Can you enlarge the font? It's quite small. We barely to read it. Okay, it's perfect. Much better.
Good.
Thank you.
Apologies for that. So yeah, so the next thing you have on here is your choice of actions. It's a discrete action space. And if you think about your neural network, the outputs of that will be a number, and each of those maps to one of these actions. So you choose up front, and once you've obviously chosen these, you can't change these later on, and you can't add extra actions in because the neural network just won't have the connectivity to represent that. So get this right up front. You've got a lot of choice between steering, how many angles it splits that down into, and the same for speed, between 0 meters per second and 4 meters per second, which 4 is incredibly fast. So for your first model, do something simple like probably 5 on the steering and 1 meter per second. And that will give you, as you can see, a permutation of 10 options that split 30 degrees down into 2 and 0. And then for each of those, you have a 0.5 meter per second and 1 meter per second, because we've split everything up. Click next. We can give it a name. So my first car. You can choose a color. The color really doesn't make any difference, but you can do that. And there you've got a car. So you can come back and modify this, but as I say, once you've trained a model off it, that model is tied to the car configuration when you first do it. So once you've done that, you can create a model either from this page by clicking create model, or you can go to your models on the left-hand side and create model from here as well. When you get first logged in, you'll see actually there are 5 models in your account which are pre-trained by Amazon to give you an idea, just to give you, if you want to do a little demo. I'll be a little tip for you, they won't perform very well in the races, so don't be hoping you can win just by using those. So let's create our first model. The first thing we need to do is give it a name. This is, it has to be unique, but it's just something meaningful to you. So we'll say my first model. Give yourself some description, because this is really useful then when you come back to try and work out what did I try that time for that model when that one does really well. So we'll say first model, lots of steering, center line reward, or something like that. You then have a choice of tracks. The current monthly track is this new one which came out just today. It is very complicated, so I suggest you start with something simple, and actually the simplest one is the oval track in here. Really, when a model trains for a track, it gets more used to that behavior. If, of course, I'm training for oval, and then I try and race it on that complicated one, it's probably going to do pretty badly. But it's also going to take quite a long time to train on a complicated track. So just for the purpose of this demo, we'll choose the oval, click next, and then you have the choices of time trial, object avoidance, and head-to-head. So start simple. Let's stick with time trial, which simply is the quickest lap you can get around the track. And then we have to choose our agents. So these are our cars. And you'll see there's the car I configured just a moment ago, my first car. And click that, and we can click next. And then you have your reward function. As I say, this is where you're going to spend most of your time and thinking about the behavior you want to reward. If you reward the wrong things, the car will not perform. And actually, there's some weird quirks which you'll start learning through the process. And with this, though, there are a number of default reward functions which are perfectly fine to get you going. And actually, if you go into here and click info, you'll see there's a lot of help information on the parameters. And so you get essentially information about the state of the car in the environment. So is it on the track, for example, or not on the track? How far is it from the center, and so on. And you can use these if you want to. The default reward function is a center line reward. And as I say, it's looking for how wide is the track, how far are we from the center, and then we can work out actually if we know the track is say 10 meters and we are 2 meters from the center, then we're quite close to the center in the process. Whereas if the track is obviously 4 meters and we're 2 meters from the center, we're on the edge. And we can give reward. So if we're near the center of the track, so we're in 0.1 of the track width, we give 1. If we're further out, we give half, and this is 0.1. This is essentially exactly the same demo as I had on my slide earlier. You then got some hyperparameters. As I say, these change the way the model gets trained behind the scenes. When you get started, don't worry about them. Don't need to look into them at all. Don't need to worry about them at all. When you do want to, you can start clicking into the guide and getting more information. But to be honest, that's probably a session for another day. So leave those for the default. And then essentially the last thing you have to choose is how long you want to train it for. So in this case, I'm going to say train for 60 minutes. And what that will do then, click create model. It will then behind the scenes go and set up a SageMaker instance for training the neural network. It will set up a RoboMaker using the track we've selected, using the car configuration, and it will start iteratively sending the car around that environment into the process there. Now, this is going to take about 5 minutes to set up, so I'm not going to show you that right now. If I flick back to my slides in sort of predefined, pre-built, this is the sort of thing you'll see, and this is one of the tracks from last year, where the car is iteratively going around exploring the track in different ways. And as you can see, it does pretty well at this point, but it's still struggling with that end corner. It's randomly then taken a left turn that's got it around, and that's a great behavior. It's now going to learn, that is a good way of getting around when I see characteristics of a track going to the left. But of course, it's oversteering, it's crashing on the inside. So it's not quite there yet. When you're in there and you're training, what you actually see in the console is a view that looks just like this. So on the right-hand side, we have a sort of, not quite bird's eye, but a just behind the car view of the car driving around and learning to drive on there. Don't be misled slightly by what you're seeing there. It's very easy to think the car's doing well, but actually it's just random behavior. It hasn't really learnt. The graph on the left is where you can really determine how well things are going. So this, as I showed you earlier, is showing you a few things. It's showing you how is your reward building up over time. And hopefully you see this going from bottom left to top right, which means the car is learning. And actually, as time goes on, it's getting more and more reward because it's getting further around the track and behaviors that is actually better for the outcome you want to. Also on the bottom is this red line. This shows at the end of each training cycle, it does a test to see, without any randomness, how is the model performing? How far around on average is it getting? And it then selects what is your best model based upon the model that got you the furthest around the track. That's the model, the point in the model, sorry, that will be used when we submit into the league. And there's a few other fun sort of angles you can get in the process if you're really interested. So that is a really quick demo, and I appreciate that was quite quick, but it is really easy to get going. If you go onto the DeepRacer website on AWS, you'll find lots of guides and things. There's a couple of links at the end of the presentation which will help you get going as well, but I can guarantee all of you can do this in about an hour, have a model that is racing around the track. Now, a little bit about the community, because the community is actually the best place to start. There's a few things to the community. We have a Slack channel, in fact, a Slack group with lots of different channels. This is a brilliant place, and it's actually probably the core of the community. If you go into there, we've got channels on reward functions, on training tips, on getting started, as well as some more advanced bits in there as well. We have a wiki and blog where we're continuing to develop documentation and information and the latest news from the environment. And to say, we're well connected with Amazon. We have Amazon representatives from the DeepRacer team embedded into the community, helping us answer questions and actually giving us, taking our feedback and giving us insights into what's coming up down the line. We also have built a whole bunch of tools, and we've taken what Amazon have done and made it better around analyzing your performance, and also by taking the Amazon stack and allowing you to run it locally on a GPU-enabled machine, which would save you training costs. But right now in May, as I say, there are no costs, so you may as well just stick with the console. And finally, we have a whole bunch of videos on YouTube on our community channel that go through these sorts of introductions through to advanced topics on anything you can think of. And it's a big community. We have over 2,000 members, and it's a very supportive community. So there's no such thing as a bad question. And the great thing we see is people like yourselves come in, you have some questions, some problems you don't quite understand, you get help almost immediately. But actually, within a few weeks, most of those newbies become the people helping the next generation. And over time, you become better and better and better. But it's a huge environment. And actually, from the 2019 finalists, the 64 who went, I think in the end we had over 40 who came from the community, and so far in 2020, all 3 of the winners so far have come from the community. So if you want to do well, come speak to us. And we are all over the world in terms of people. This is not localized to the US or any particular geography. And there's always someone online racing. And really, as I say, it's a great place for you to connect to the rest of the community, to find people, to get answers to questions who've already been there, already done, experienced the problems you may have had, or answered the questions that you've learned. We also have a lot of experts, both from Amazon and from people who've been racing for over a year now in the process there. And it's just a great way of connecting with like-minded people and expanding the skills in the process. We've actually extended the community to also include some of the other AWS machine learning products, such as Deep Composer and Deep Lens, but we won't cover those in this session today. And the other key thing we do is meetups. Obviously not right now during COVID, these have all been cancelled, but we have, particularly in London and New York and Singapore, we have been running monthly meetups and typically getting sort of 50, 60 people. We normally have a track and cars, and it's just a great way of trying out your models in the real world. So we're hopeful these will restart in due course at some point, but watch this space. And so, yeah, how can you get started? So first thing to do is sign up for an Amazon account if you haven't already got one. It's completely free. You will need to put in a credit card. But as I say, through May, the cost of DeepRacer will be reimbursed, so that you shouldn't have any bill at the end of the month. Number 2, come and join the community. Head over to deepracing.io, and there's a link right at the top that says join, and that will take you to the Slack community where you can sign up and come say hi. And when you do join, you'll probably get a message from me welcoming you to the community and saying hello. So feel free to let me know you found out about it from this talk, because that's great feedback. And then follow a guide. So there are certainly 2 ways you can do that. There's the official Amazon guide. If you go to the training website on Amazon, they've got a 90-minute e-learning course which steps you through what I've done in a bit more detail and gives you a bit more context on some of the things like the hyperparameters and how they behave. And we also, as I say, on our YouTube channel for the community, have a whole bunch of videos of getting started in the process there. Build your first model. The best way of learning is by trying and seeing how it performs and seeing how it doesn't perform. And then finally, enter the league and win prizes. But don't forget, it's free this month, so it's a great time to get started. And absolutely, the community is here for you to actually help you on that journey if you get stuck at all. But I can guarantee you it's a lot of fun. It's probably really addictive as well, but it's a good way of getting your head around machine learning, but particularly reinforcement learning in a much more practical way. So that's the end of my presentation. So I'm more than happy to take any questions from anyone about what I've been speaking about.
Great. Thanks, Linda, for the great presentation. And we have quite a lot of Q&A questions in the Q&A. Can we go through from the top one by one?
Absolutely. So let me let's try and get that up on my screen. Okay, I'm going to stop sharing my screen so I can get back to Zoom.
Okay. Yeah.
To the questions.
You can just click the Q&A.
Q&A. I haven't done this before. Oh yeah, I see Q&A. Right. Okay, so let's go through some of these questions then. Okay. I guess I'll go from the top. So Nate's asking, can you write your own reinforcement learning models algorithms from scratch and then upload them, or do you have to use a preset model? If you do them from scratch, do you have to adhere to some sort of API or work with DeepRacer? So through the console, you've got a choice of 2 different RL models you can use. But pretty much everyone is just using the default model in there. You can't, through the console, change the algorithms, but as I say, the community have taken the whole stack and allowed it to run locally. And in that environment, you can do anything you want. Yeah, if you're super keen, if you've got some really interesting reinforcement advanced models, you're probably going to get a good edge over other people, because most people are just using the default models. Because really, of course, this is about learning from scratch and building those base skills. So yeah, in the console, no, you just get 2 choices. But offline, locally, you can do anything you want. In terms of executing, of course, it's just taking the output model. And so it doesn't really matter how you've trained it, as long as the model fits the right structure into the process there. Okay. Second question then from Nathan here. Do you need to have a simulation environment? For example, what if you wanted to use reinforcement learning for something like dynamic pricing, and with reward equals pricing and actions being increased, decreased price? So in terms of, you need to be able to simulate your problem space. It doesn't necessarily have to be a 3D simulation, a physical simulation of this. So in terms of, these questions jumping around there. So in terms of doing like a dynamic pricing, you could simulate, for example, a web platform and users interacting with that platform and seeing the behaviors and outcomes. But you need to be able to simulate the characteristics that will have a big impact on your outcome. So as I say, in the racing, that is friction and gravity. In a dynamic pricing, you need to make sure you've got, for example, does weather have an influence on there? And for pricing modeling, you may be better for a supervised learning where actually you've got historical outcomes where a certain price reached a certain outcome. But there's definitely things you can do with e-commerce platforms where you can plug in one of these things behind the scenes and let it learn along the way. But not many e-commerce retailers are willing to gamble like that. Next question from JP Gerber. You mentioned that the reward functions are a very important part of reinforcement learning. What types of reward functions are used? So the reward function is a simple bit of Python. It can be as simple as one line long. Actually, if you write a reward function that says return 1, and the model will actually still learn to drive around the track, because when it's on track, it gets a reward. And when it crashes, it naturally doesn't earn any more rewards. And it will take quite a long time. It won't be a fast model. But actually, in terms of reward functions, there are a number of examples given in the console. There's more in the community on Slack as well, where people are generally actually quite open. If you Google, you'll find lots of examples. But you know what? The best thing are the simpler rewards. If you've got like 1,000 lines in your reward function, you probably have thought it. The most effective reward functions are ones that reward the outcome you want to try and achieve, rather than progress and making progress fast, rather than the example I gave you about positioning on the track and trying to find a default line in the process there. In the next question then on here from Jay, in the reward process, it might go on loop as well. How do we control that? Yeah, so the reward process generally is a cycle, right? Every time the car takes a step, it calls the reward function, it asks for a value, and that is what's being fed back into it. Of course, you could have a bug in your reward function that puts it into a loop, and that's just something for you to debug. You would find it pretty quickly because the model wouldn't carry on learning, so do keep an eye on it. But if you stick with some of the default examples and keep your code simple, you shouldn't really get stuck into holes like that. Okay, the next question from BK, what neural network topologies are adequate? So in terms of this, really, DeepRacer has a network topology kind of predefined, and really, so the only choice is whether you have 3 layers or 5 layers up front to guide that. So other topologies, I'm not saying they're not supported, but they're not really supported by the community because it's not something many of us have actually tried with. But if that's something you want to give a try, then we're more than happy to try and help you in doing so. But generally speaking, the topology, the default one, is the one that everyone works with in the process there. Next question from Andreas. DeepRacer hardware, is the hardware still based upon ROS or ROS2? I don't know the answer to that one, actually. I know they have been updating the car for the new Evo. I don't know whether that's still in ROS or ROS2 under the hood. And so ROS is the robotic operating system that drives the context around this. If you come and ask me that question in the community, I'm sure someone will know the answer to that. But off the top of my head, I'm afraid I don't. Okay, so next question is DeepRacer hardware. How is it to transfer DeepRacer concept to different platforms? So for example, the NVIDIA Jetson Nano or the Google Coral. So I guess there's 2 ways of answering that. How well can you take the DeepRacer environment and apply it to different hardware? And how well could you take different environments and apply it to DeepRacer hardware? So actually, in building DeepRacer, the AWS science team tried all sorts of different models and hardware, including the NVIDIA Jetsons, and they had mixed experiences across those. They ended up on the custom build car that they've got. It's not too small or too big to make it practical or impractical. So it absolutely is possible. What you have to do, though, if you want to run it on other hardware, is you need to get more heavily involved in RoboMaker and altering the definition of the model of the car and the characteristics of your actual hardware. That's not something the console supports directly, but actually, if you go behind the scenes and use RoboMaker directly, you can actually configure that to do those sorts of things. And there are lots of open model libraries that you can plug into that. In terms of bringing other platforms to DeepRacer, I'm not aware of anyone who's tried that. Ultimately, it's just a basic set of inputs and outputs, so it should be pretty doable, but it's not something there's much documentation on how to do. How are we doing for time? Are we still okay? I guess I'll take a few more questions.
Actually, there are two questions at the very top. I'm not sure did you miss that. There actually quite a few votes for that questions at the very top.
Yep, I just see that. I did start at the top, but people will keep coming in naturally more. So
yeah, I know.
Top one now says
like the order keep changing.
Yeah. Sherman asked, I wondered what kind of reinforcement learning algorithms people advocate. I've heard Q-learning and some of the descendants, DynaQ, etc., that they are all very similar. Is there a default algorithm that is best or preferable or more intuitive? You know, in terms of more broader reinforcement applications, it obviously depends upon the problem you're trying to solve and which algorithm works best. I say for DeepRacer, the one that's default in the console is pretty much what everyone's using. I can't off the top of my head remind me of those. So I'm afraid I don't have any more guidance on the variants of those. I don't think many people in honesty are at that level of tinkering with it. It's really about getting people who are just getting started into there. But you know, we'd love to have you come and explore that with us in the community if you'd like to. Let's see, the next highest question, which I don't think I've answered, was from Rainier. Is there some way to do transfer learning from one track to another? I start on the oval and progress to the harder ones. Absolutely. So one thing I didn't show you in there because we didn't have time was when you finish training your model, you have a choice. You can either, well, we have three choices. You can submit it to the racing and the competition and see how it does. You can decide that it just hasn't performed well and you want to start again, which is fine. Or you can transfer the learning you've already done and tweak it. And absolutely, you can clone your current model. You still have to keep the same actions space, as I mentioned, that's fixed, but you can put a new reward function in or improve your reward function, or simply try it, as you suggested, on different tracks. And that will help it learn different behaviors and become a much more generalized model. In terms of the virtual racing, actually, you probably want to overfit your model as much as that's normally a naughty word, a naughty thing to do. For the racing and the virtual racing, overfitting to particular tracks is probably the way you get fastest. But yeah, absolutely, the transfer from that to the real world doesn't work well. You do need to train on different tracks because that gives it a lot more experience. And of course, the physical track is very imperfect. You've got shadows and different lighting and things like that into the process. But if you start on oval, the model will train very quickly. It will obviously only turn left. It won't have learned turn right. But it's a good place then to actually bring that then to a more complicated track where at least it won't be crashing all the time and it can tweak its behavior into the processor. So yeah, transfer learning is very much a part of DeepRacer. Okay, so I think I've answered the next couple down here. Okay, so the next one I'm seeing in here, I'm not going to pronounce that name, but how frequently do you compute the reward function after each step or after every few steps? Intuitively, it seems if we compute after each step, then we only reward short-term results, but not long-term results. Fantastic question. So we do compute the reward after every step. However, we only learn from the aggregate behavior every n cycles, n episodes. So the default is every 20 episodes, it will retune, re-optimize the neural network, and then use that through the next 20 episodes. Now, in doing so, you're right, each individual step it will have a reward, But one of the hyperparameters I skipped over is something called the discount factor. So this is actually trying to very much deal with the problem you described, which is maybe this individual step is not a great step, but by taking this bad step, it unlocks 10 new amazing steps because we get ourselves into a better position to get it around the next corner. So the discount factor actually says how many future steps to take into consideration, and we aggregate the reward across those number of future steps in a discounting way. So the nth step away is a much smaller contributor to the second step and the third step in the process. And so actually this is one of the things you can tune, and the default is actually 1,000 steps, which is probably too much, but you can set that anywhere between 1 step and 10,000 probably, but somewhere between 50 and 100 is a neat place to be, and that will actually help the car to learn about longer term behaviors rather than just short term ones. Another question from the same person: how do you balance exploration versus exploitation? So you don't need to balance that. The car will carry on exploring until it's getting more confidence. And the way it does this is through entropy. Again, one of the hyperparameters you can set is how much entropy or randomness the car should take when exploring the environment. But as the training session progresses, the car should get more confident. The car should be able to say, I took this action and I expected to get that reward. As it gets more confidence and it does get the rewards it expects, it lowers the entropy, it lowers the randomness and sticks to more exploitation, because then it gets it further around the track into new situations where it comes across, I thought I was going to do well and I didn't do well, and it focuses behavior on training those elements. So you as the master overseeing this don't need to decide between exploitation and exploration. The model will naturally do that. But of course, once you have got to a point where it's finished sort of exploring and it's got the best it can, there is very little point in training further into the process there.
Hi, Linda.
Yes.
I actually lost track of which questions you answered, which one not. I think we still have quite a lot. We are over time. Maybe we can pick a couple of more to answer.
Sure. Is there any particular ones that jump out for you, or will I just go down?
I don't know. Maybe still go to the go to the top, and
Okay.
you know, some people vote. I'm not sure that one you already answered or not.
I think, yeah, so do I just click answered live, do I? Yeah, I'll wait on that one.
I think if you answered,
okay,
you
so
can just click dismiss.
One at the top, a car will, okay, yeah. So I don't think I've answered this one. So it appears that from the given example, a car will not learn to drive straight or on the right or left edge going straight, but only middle of the road. How would you address that limitation of the example? So yeah, so the example I gave, the reward function tries to keep the car in the center of the track, and we're rewarding for being in the center. So we're not only rewarding for turning left or right or keeping straight. The car will learn that actually as the center line bears one way or another, it needs to select the right action to keep it in the center. So you do have a challenge there, which is after a while, particularly something like this, the car will learn to start wobbling. It's perfectly safe to stay on the track, but it starts to learn that if I wobble from left to right, I take more steps, and therefore I'll get more reward. So it's not the behavior you want to get. And so the example I've given actually do end up leading to that sort of behavior, but you can then obviously enhance your reward function to compensate for that in the process. So let me answer that one. I have done this one as well. So let's see. Okay, how do you factor into the reward function other complex issues such as avoiding collisions with other cars or sections of the road that are slippery or driving on the edge because there is another car already in the center? So yeah, you can ultimately build a very complicated reward function. In terms of avoiding collisions, the car will naturally learn that behavior because obviously when it collides, it comes to an end of an episode. So the discount factor I mentioned earlier means it's not getting any future reward because it collided, and therefore it will favor actions, even if your reward is pretty low on them, that get it around the collision, because it will then get many more steps, and that will be accounted for in the process. Now, that said, in the reward function, one of the things you do have are the locations of the other vehicles and your proximity to them. And so you can actually build a reward that says, if I am within, say, 1 meter of an object, then lower my reward, and the car will learn quicker to avoid a collision in doing so. But ultimately, it's a question of trading off complexity in your reward function for the amount of time it takes to train the model. Okay, sure. So maybe just one more, I guess. Then are all the options, the car, the reward,